If you've got x to the power of a half, that means you want to square root x. If you've got x to the power of a third, that means cube root of x. If you've got x to the power of a quarter, that's the fourth root of x, and so on. So more generally, if you've got x to the power of 1 over n, that just means the nth root of x. Let's go through and add some examples to those. So if we start with x to the power of a half again, 16 to the power of a half, that's the same as root 16 square root, which is just 4. 8 to the power of a third, that would be cube root of 8, which is 2. 81 to the power of a quarter, that would be the same as the fourth root of 81, which is 3. And if we say maybe 32 to the power of a fifth, that's the same as fifth root of 32, which is 2. So what happens when you've got a more complicated fraction? So if you've got x to the power of a over b, the general rule says you're going to do the bth root of x to the power of a. Another way of thinking about that is you could do the bth root of x first, and then whatever answer you get, you can put that to the power of a. This one definitely will make more sense with an example. So let's say we've got 8 to the power of 2 thirds. First way of thinking about it could be the cube root of 8 squared. That would be the cube root of 64, which is 4. If we think about it using the other way, then we're going to have the cube root of 8 first, and then we're going to square it. If we look at that, that is the cube root of 8, so 2 to the power of 2, which is 4. So either way you get 4, it just depends on which way you want to look at it. Just to go back and add some notes to that, when you've got these kind of fractions as your power, whatever is on the bottom describes what kind of root you're going to do, and whatever is on the top of the fraction is going to describe what power you want to use. Okay, so now we know the rules for working with fractional indices. I have 6 examples to work through, and they do get a bit harder as they go on. Find the value of 100 to the power of a half. So if you remember, power of a half just means square root. So we're going to do 100 to the power of a half equals the square root of 100, and that's just 10. Example 2, find the value of 64 to the power of negative 1/3. Now this relies on some knowledge of negative indices as well, which I did cover in the previous video. If you've got 64 to the power of negative 1/3, you can think about that as 1 over 64 to the power of a third. And that means 1 over cube root of 64, which is 1 over 4. I'm going to show you a different way of thinking about this one. So if you want, you could start with 64 as being 64 over 1, and that is to the power of negative a third. You could think about dealing with the negative as flipping that fraction upside down. So you would get 1 over 64 to the power of a third. Now that you've got that, you would just apply the power of a third to the top and the bottom, and that is the cube root of 1 over the cube root of 64, which will give you 1 over 4 again. So again, just a different way of thinking about the same problem. Example 3, find the value of 9 over 4 to the power of minus 3 over 2. So we've got another negative power here, meaning we've got to deal with that negative first. For this one, I definitely just flip the fraction upside down first to deal with the negative. So I'd do 4 over 9 to the power of 3 over 2. And then I would deal with that fractional power. So the denominator tells us what kind of root it is, and the numerator tells us what kind of power it is. So for this one, I would do the square root of 4 over the square root of 9, and then raise both of those to the power of 3. So separately, that would be 2 over 3 to the power of 3, and then 2 cubed over 3 cubed, which is 8 over 27. Example 4. Involving some algebra. We've got 16 to the power of 1/5 times 2 to the power of x is equal to 8 to the power of 3/4, and we want to work out the exact value of x. For this type of question, the best thing to do is to take any of those bigger numbers and write them as powers of the smaller number. So by that I mean we could take 16 and write it as 2 to the power of 4 instead. So we'll have 2 to the power of 4 to the power of a fifth times 2 to the power of x, and then we can rewrite 8 as well to be 2 to the power of 3. Benefit of doing that is now you can apply some of your previous power laws where you've got 2 powers next to each other, meaning you just times the powers. So we get this. 3 times 3/4 is 9/4. And now again, we can think back to our previous power laws. When we've got two numbers times together that both have powers, we just add the powers. So we're going to have 2 to the power of 4/5 plus x equals 2 to the power of 9/4. Now, if you look at this, we've got 2 to the power of something on both sides. The only way those two are going to be equal to each other is if the powers themselves are equal to each other. So if 4/5 plus x is equal to 9/4. And that can then lead you to your answer. You just got to work out what x is. To do that, you would do x equals 9/4, take away 4/5. And that you can either do on the side or in your calculator. And you're going to get 29/20 or 1.45. Example 5 is quite similar in that we've got some bigger numbers and a smaller number too. So I would take those bigger numbers there and rewrite them as powers of 2 again. So instead of 4 to the power of k plus 3, I'm going to write it as 2 squared to the power of k plus 3. 16 can be written as 2 to the power of 4, and then we've got times 2 to the power of k. Again, we can use our power laws. 2 powers next to each other like that means we're going to times them together. That's going to give us 2 to the power of 2k plus 6 equals 2 to the power of 4 times 2 to the power of k. Then on the right-hand side, we can use the power law about adding the powers. So we can do 2 to the power of 4 plus k. And on this side, we've got 2 to the power of 2k plus 6. And again, because we've got 2 to the power of something on both sides, the only way that's going to be equal is if the powers themselves are equal to each other. So we get a nice equation in k, which we can then rearrange and solve. However you normally do it, I would probably take away the k from both sides first, and then take away 6. So you end up with k is equal to -2. Last example, bit of a weird one. Given that 5 to the power of negative n equals 0.5, find the value of 5 to the power of n to the power of 3. Okay, so when I'm looking at this, the first thing I'm thinking is it's not helpful to have that written as a decimal. It would be much easier if 0.5 was written as a half. So that's where I would start. Then I would want to deal with that negative power. So I'd rewrite 5 to the power of minus n as 1/5 to the power of n is equal to a half. And now we're in a situation where we can cross multiply. So when you've got two fractions equal to each other, you can use cross multiplication. And that tells us that 5n times 1 is equal to 1 times 2. So 5 to the power of n equals 2. And now we can work out finally what 5 to the power of n to the power of 3 is, because we just raise that 2 to the power of 3 as well. And we get 8. That's it for now. So if you found this video helpful, please do like, comment and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it useful. Thanks and see you next time.